program lead for the operations division's performance measures and data analytics. Katie specializes in mining and analyzing traffic data. She develops reports and tools for regional VDOT staff to monitor traffic performance. Katie received her Bachelor's of Science in Civil Engineering from Virginia Tech and an MS in Civil Engineering from the University of Virginia. She's been with the Virginia Department of Transportation since 2012. Katie?
Good morning, everyone. I had a lot of technical issues in the last 30 minutes, but hopefully everything will be running smoothly now. I updated the slides. These are an older version, so I'm just going to wing it. But today I'm going to be demonstrating several tools that I made related to the new MAP 21 performance measures for travel time reliability. So as most of you probably know, there are some new federal performance measures for transportation, and particularly I'm going to be focusing on the ones for reliability. I've developed these interactive data tools because as we all starting to digest the data and the measure, there was a steep learning curve. And so these tools were designed for both VDOT staff and the MPOs around the state of Virginia to help get familiar with the measure, the data, and starting to look at target setting. So I had another slide that broke down the actual measures, but it's not here, so I'm just going to try to talk through it. Those of you who know the new reliability performance measure, it is pretty complicated, so bear with me. Basically, there are two measures for the system reliability. They break it down into interstate and non-interstate. And the measure is called percent of person miles traveled that are reliable. And they define reliability using something called the level of travel time reliability, which is the 80th percentile travel time on a segment over the 50th percentile travel time. And if that ratio is greater than 1.5, the segment is unreliable, otherwise it's reliable. And then they sum the person miles traveled over the unreliable segments, or the reliable segments over the total. So it's, those of us who are familiar with the buffer time index or the planning time index is not those. So we had to learn this new measure. So it was a steep learning curve for everybody. So I designed this tool to help get into that. So if you can switch me in the back to the computer. Okay, here we go. So this is an interactive dashboard that I made for, like I said, both VDOT and also the Virginia's MPOs, because everybody needed to learn the measure and then also start focusing on target setting, like I said. So this, I started working on this a couple years ago, and the way it works is you can select either your VDOT district or your MPO, Metropolitan Planning Organization. You can select which year you want to look at the data for. You can select interstate or non-interstate. These are the 4 time periods that the federal measure looks at. And then finally, this sort of rolls up that person miles reliable. So the way this works is, if I wanted to look at Northern Virginia District, I can click on a link. I can see what that reliability score, that LOTTR is by each time of day. And the measure takes into account the worst of the 4 time periods. So so this was helpful so that everyone could start getting familiar what the reliability actually looked like in their specific area. The metropolitan organizations are really only concerned with their grouping, so we can look at let's see here. Like you can see here for Richmond, there is one that is over the threshold. It's at 1.66. It's just on the weekend. So if they wanted to start looking at, this is 2016, if you want to start drilling down into what kinds of projects or initiatives are improving reliability, you can look from year to year. We can see actually in 2018 that segment is no longer orange, which means now it's considered reliable by the measure. So that was sort of the main dashboard for everyone to start, like I said, just getting familiar with the actual performance measure. Then there's a couple other tools that I made here. So this one is getting a little bit more into the details of the measure. Like I said, the way the measure works is if one time period is unreliable, then the whole segment is considered unreliable. And this was something where when we started digging into the target setting process, it was an aspect of the measure that we really had to think hard about, because if you improved reliability during one period, like the weekend, but the AM peak period was still unreliable, this did nothing for your overall reliability measure percentage. So we wanted to get a feel for how big of this problem was. So this is looking at how many segments are unreliable. So and the segments are the TMC codes, if you're familiar with those. And there's only actually 4 TMCs where all 4 time periods were unreliable. But the trickier ones is when there was 2 or 3, and if we improve one segment, that segment is still unreliable. So I had a good example. Okay, we go to Fredericksburg. Yeah, like this one is. This one has 3 time periods here that are unreliable. The weekday AM is actually reliable, but the midday, PM, and weekend are all above that 1.5 threshold. And again, this dashboard allowed the user to select which year, which MPO, etc. So then the last thing, and still moving towards target setting, when we were starting to think about what would be a meaningful target for the region, we need to look at how this measure changed year to year. So this dashboard is just showing the segments that changed, that had a LOTTR change of plus or minus 0.025. And so that's what's being shown here. So I had an example. Okay. So there was a segment here that was yellow. Oh, okay, sorry. These segments became green in 20. These segments that are green means that there was a positive reliability change in reliability. Yes. Okay. Sorry. This was the example I wanted to use. So this means that from 2017 to 2018, you can see that the level of travel time reliability during the AM went from 2 to 1.2. It was green on the map. And so this shows that maybe there was a project that we did between 2017 and 2018 that improved reliability. So in this case, if you know this area of Virginia, the express lanes, there was an extension that opened at the end of 2017. So it's possible that this section in the morning became more reliable due to that project opening. So by being able to drill down on the data at this level, we could really start getting into what projects were actually influencing the reliability. So that is that covers the sort of a high-level overview of this tool that I had designed for VDOT staff and MPOs to look at for the reliability. And I'm going to show one other thing. Because after VDOT started looking at the federal measure, a lot of the question came up was, is this the best measure for Virginia? If we want to have our own, we're going to meet the federal requirements, we're going to do the target setting, we're going to present the measure, but if we want to develop a measure for Virginia, or a set of measures for Virginia to look at reliability, maybe there's something better that we could be using. So that is what this dashboard is showing. This is comparing different reliability measures. And so you're able to look at the same segments of road using the same scale and compare how different measurements look on the same road. A few things I did differently here is the other tool looked at the TMC segments, which can be very small. These I rolled up into longer corridors because that was part of the discussion we had about reliability. Is it meaningful to look at region-wide or corridor-wide or 1 mile segments, 2 mile segments, that kind of thing. So this is, if you look on the map, you can see they're sort of like bigger segments. They're about 8 to 10 miles long. I think it was important to think about sort of the geometrics because when we're thinking about like actual projects that could improve reliability, it maybe is more of like a program that is applied to a wider area as opposed to like a spot project in some cases. So that was why when we were looking at these measures, that was one change that was made. So the way this tool works is again, you can select the district or the interstate, and so we're going to do that now. Let's see. We'll go back to Fredericksburg. And so the color scale is the same for all of them, which it talks about at the top. I guess statewide you can see. So between the orange and the yellow is that 1.5, and the bottom box is that LOTTR, the same thing that is used for the federal measure. So you can compare the federal measure in the bottom right to some of these other measures. There's PTI up here that we're familiar with. This one is the 80th percentile speed over the free flow speed, and this is the 80th percentile speed over the posted speed limit, which were some ideas that our Secretary of Transportation specifically wanted to look at. So just to illustrate one example of where you can see sort of the difference between the types of reliability measures coming through is this segment in Fredericksburg. So it's yellow. This is Fredericksburg. This is 95 South, and it's yellow, which means technically by the federal requirement, the rules, this is a reliable segment. But if you look over here, so once you click a segment, it brings up a lot more details about it. You can see like the PTI, the BTI, a lot of these other measures, they're red, saying that this is an unreliable segment. But the federal measure is yellow, meaning technically it's reliable. And you can see why, because, so this is for the PM period. The 50th percentile time is much higher. So this is a little bit more of that reliably congested sort of example. So technically it's reliable. So when we were thinking about what would be a meaningful reliability measure for the state of Virginia, these were the kind of things we wanted to keep in mind. Were we actually capturing the types of problems that we thought we were capturing? That kind of thing. So this visualization was basically used to help us see the differences between the measures and for future measure development so that we know, how the data behaved on the Virginia roads. But that was just sort of a really quick overview demo, but if there's any questions, I'm happy to answer them.
What's the underlying data source that you're using for this?
Yeah, so for the first tool that I showed, which is sort of the federal requirements, we started with using the NPM RDS, which is the National Performance Measure Reporting Data Set. We did switch to using INRIX eventually, though, and I think the state can choose to use INRIX if they want to. Yeah.
Do you see the tools that you developed kind of being something more sustainable and applied year after year? Is this caught on internally?
Yeah, so it was very popular among the metropolitan planning organizations because at the early stages, I think they were really eager to get their hands on the data and to actually see what it looked like on their roads. So there was definitely a lot of interest at the very beginning, like I said, just getting it started. As far as sustainable, I think there's definitely a need for tools like this so that we can monitor performance, whether it be this kind of thing or something else out there. I couldn't really say, but it definitely met the needs of what at the time. Yeah.
Kind of a follow-up question. What led to the design principles that you applied to the application? It's very map-centric as opposed to maybe coming into it from a table and then creating a map. What drove some
That's
of your
a good
design
question. Yeah, I sort of went with I guess we went with a map just because in a lot of cases when we were working with sort of local organizations, they're so familiar with their own roads. They know what the problems are. And so I think it's easier for them to look at the map and identify areas that they already, perceive as reliable or unreliable. So that was sort of why we went with the map initially. And then a lot of the other sort of features here, like even this one that I was showing with the table on the right, I was meeting with the teams from VDOT in the traffic engineering and operations arena, and it was all, sort of, can we add this? Can we add this in like the cumulative distribution function here at the bottom? That was something that someone wanted to see just so they can really visualize, they're more of a graphical visualizer, so yeah.
In order to generate these average speed maps, are you processing GPS data directly from transit vehicles and then generating these?
So this is INRIX data, so they're doing all the heavy lifting.
It's already an average speed map.
Yeah.
Please?
Yeah, so you mentioned that you moved from MPMRDS to adopting INRIX. Presumably INRIX has a more comprehensive coverage of your roads than just the National Highway System. Did you expand to, this analysis to covering roads that wouldn't be part of the NHS?
I did not do that, but like you said, you could do that, but I did not with this phase of designing these tools.
Right
no.
now it's just, is the NHS
Yeah, with like this particular one is really focusing on the interstates. That was sort of, when we were trying to develop a reliability measure for Virginia internally, we started with the interstates and the freeways, and then we'll sort of move down to the other corridors.
At the front here, please.
How has this information changed your programming decisions?
I would say that is definitely still in the process. We're still spending a lot of time talking about project level impact on reliability. But I do think we spent a lot of time taking this data and like coming up with examples of projects that we thought influenced reliability that then we can sort of plug in and look at on that level. So I mean, it's definitely still an ongoing process with respect to that.
And our last question here on the second.
Have you made any adjustments to the tool based on feedback from the engineers?
Oh, I've made tons of adjustments. I mean, sometimes it was like sort of like little usability type things, but I can't really think of any like big example right now. But there was a lady in the Richmond MPO. We had a great dialogue where she was really into using it. So anytime she was like, well, I would really like if we could do this kind of thing. So that was really good working relationship.